Bonjour tout le monde, Michael Sinatra, le directeur du Centre de recherche interuniversitaire sur les domaines numériques à l'Université de Montréal. C'est mon grand plaisir de vous accueillir tous ce matin pour notre conférencière invitée Laura Estill, and I'll switch to English. It's my great pleasure to welcome Laura to Montreal, her first time here at the Université de Montréal. She had a brief architectural tour of the building just before getting lost in the building with me. This morning we're very excited to welcome her to hear about new research that she's going to share with us for the first time. Laura is a Tier 2 Canada Research Chair in Digital Humanities and Associate Professor of English at San Francisco Xavier University in Nova Scotia here in Canada. And her research explores the reception history of drama by Shakespeare and his contemporaries from their initial circulation in print and manuscript to its online transmission today. And overall, you can always see in her writing how her model reflects and how to conduct digital humanities research in the digital age related to that topic. So without further ado, please join me in welcoming Laura Estill for her talks on Shakespeare as the digital proof of concept.
Merci pour la chaleureuse accueil. Ça me fait plaisir de vous rejoindre. Aujourd'hui, je vais faire mon exposé en anglais, mais j'invite les questions en français à la fin. Et je tiens aussi à remercier Erin Morrow et James Hughes pour leurs sages conseils sur cette recherche. Because of Shakespeare's centrality in the English literary canon and popular culture, many tools for computational literary studies use Shakespeare as a proof of concept or test case. As Alan Gailey's The Shakespeare Archive demonstrates, digital Shakespeare texts themselves are the product of choices that are usually not made legible to the reader. These texts are then often fed into algorithmic black boxes that can elide their complexity further. In this talk, I turn to some tools and resources that use Shakespeare's work as their starting and sometimes ending point of investigation in order to consider the assumptions made by creators and users of projects. When digital tools are created with Shakespeare as the test case, Shakespeare's work shapes how the tools ask questions and what questions can indeed be asked. Well, how do I change my slide?
Try to click on it.
Oh, there we go.
Yeah.
Why is Shakespeare so often used as the first example for a digital tool? In some cases, it's because Shakespeare's text is readily available online. There are over 50 million Google search results for Read Shakespeare online. Alan Gailey, Eric Johnson, and Andrew Murphy offer lovely histories of these digital texts. It's not just texts of Shakespeare's plays that are available, it's also facsimiles. When many early books are not digitized at all, there are currently 25 separate digitizations of the first folio alone. In her analysis of these folios, Sarah Werner says, "It should hardly be surprising that there are multiple copies of this fetishized object online." In my article, Digital Humanities Shakespeare Problem, I point out the many factors at play about why there are more digital projects focused on Shakespeare, from Shakespeare's cultural prominence to career considerations for scholars to funding opportunities. So among the reasons that Shakespeare is often used as a test case is because Shakespeare can be used, and with what seems like relative ease, because of existing digital texts. The most popular Project Gutenberg Complete Works of Shakespeare ebook, and there are many. Oh, we'll go back. Missing a slide there. Has been downloaded over 100,000 times in the last month. The just add Shakespeare approach seems easy, and it also seems like something that non-experts can do. This trend of turning to Shakespeare first as a test case or proof of concept, though, is not unique to the digital. As Nima Parvini explains, although it is not always the case, the tendency is for critical debates to be fiercely contested in the realm of Shakespeare studies before filtering through to the rest of the discipline of, in this case, English literature. Christopher Norris traces this back centuries to Samuel Johnson positioning Shakespeare as the test case and touchstone for literary values at large. In literary studies, as in the digital humanities, Shakespeare can be the starting point for better or worse. Many different disciplines use Shakespeare as a test case. Computer scientists, for one. 3 computer scientists from Columbia, for instance, Prerna Kashyap, Samrat Fatale, and Ido Drori, developed a program to analyze art and then apply a caption to it automatically in what else Shakespearean language. As their introduction states, our goal is to have a neural network describe the painting artistically in a style of choice. As a proof of concept, we present a model which generates Shakespearean prose for a given painting. As you can see, when they say Shakespearean prose, they don't mean prose by Shakespeare, or to a literary scholar, prose at all, but words in a Shakespearean style. We might not be surprised to see Shakespeare used as an example, sometimes alone or sometimes one of many, to show the value of different digital tools, such as stylometry or sentiment analysis. Indeed, McDonald P. Jackson's book, Applying Stylometric Analysis to Shakespeare, is even titled Defining Shakespeare, Pericles as Test Case. The bulk of articles about Shakespeare in the journal Digital Scholarship in the Humanities focus on applying stylometric technologies to Shakespeare, though, of course, that doesn't mean that the bulk of stylometry articles are applied to Shakespeare. In a larger work from which this talk is taken, I have other sections focusing on visualizing Shakespeare and how Shakespeare is often used as a test case for teaching in online tutorials in classrooms. Today, however, I'm going to focus on Shakespeare the test case in a different way, Shakespeare as default, which results from his readily available digital text. One 2017 paper by Renato Fabri and Luis Enrique Garcia, for instance, applies principal component analysis to the works of James Joyce. In their words, where the text to be analyzed are observed against Shakespeare and the Bible, regarded as reference literature. And yet, what literature is the reference? As you know, as digital humanists and textual scholars, there's no one singular text of Shakespeare, just as there is no one singular text of the Bible. As I explored in my chapter on Shakespeare and disciplinarity, Shakespeare is often used in academic contexts by non-Shakespeareans, running the gamut from one-off quotations to extended explications. With data science and machine learning, we can add another, Shakespeare, the baseline. Archive, which is archive.org, not to be confused with the Internet Archive, is a repository of physics, mathematics, computer science, quantitative biology, quantitative finance, statistics, electrical engineering, and systems science and economics paper. And the database currently returns 45 results for Shakespeare. The bulk of the papers in Archive that mention Shakespeare do so in the context of LEAF. LEAF is a benchmark for federated settings. Federated settings contribute to federated learning, which is a way of training algorithms on multiple data sets. It's a kind of machine learning. The creators of LEAF describe it as a suite of open source data sets, an array of statistical and systems metrics, and a set of reference implementations. Shakespeare's works are included in, to use their words, a curated suite of realistic featured data sets. The other data sets in this, as you can see, they're listed here, include Feminist, which is based on the extended MNSIT, the Modified National Institute of Standards and Technology database, which is an image of handwritten numbers used for optical character recognition and image processing. There's also Sentiment 140, a corpus of 1.6 million tweets rated for sentiment based on the emojis they contained. It's used for, as you can guess, sentiment analysis. Celeb A is a database of celebrity faces. And the last non-synthetic database that LEAF presents is, you guessed it, Shakespeare. This works of Shakespeare is presented as valuable for next character recognition. Of course, here the word character is not used to mean literary character, but rather to mean character in the data science sense, which correlates most closely to the typographic sense in literary and textual studies, a character being a letter or a punctuation mark, or as they define it, a byte of information. Next character recognition is used to decipher language in applications such as OCR, that is optical character recognition. Next character recognition is also used beyond language applications with things like DNA. Shakespeare is the only literary work in the LEAF project. Depending on context, Shakespeare's language might be problematic for next character recognition because it offers a historical English, and as far as English goes, it's not a particularly large corpus. Why is it important that Shakespeare is included as a data set in this single digital project? Because LEAF is a benchmark. and Shakespeare then is part of that benchmark. As the papers on arXiv indicate, data scientists are training their projects on Shakespeare. There are already dozens of papers that do so, and the original Leaf paper was only published 3 years ago in 2019, first presented at the Conference of Neural Information Processing Systems. And according to the Internet of Federated Things project at the University of Michigan, the feminist and Shakespeare datasets are commonly used for testing federated learning framework. So what are we actually testing our language datasets against? Leaf, like many other projects, uses Shakespeare's plays as presented in Project Gutenberg. And I'll explain how they adapt the Gutenberg text. Rebecca Niles and Mike Poston, in one of their articles talking about encoding Shakespeare for the Folger Digital Text series, lament that readers will use whatever digital texts are available. The Gutenberg and also the Moby Shakespeare text have proliferated online, as Eric Johnson and others have demonstrated, which leads to their use elsewhere, for instance, in print-on-demand books, like Whitney Chrétien talks about. Shakespeare as data set raises the same questions that Shakespeare's text does. How good does a data set need to be useful? Multiple scholars have grappled with this question. Catherine Rowe asks about the good enough digital Shakespeare incunable, as she puts it, and asks, good enough, and for what purpose? Textual scholars like Suzanne Gossett and John Levin-Nino raise concerns about the quality of these texts. Jonathan Hope and Michael Whitmore, who have written some groundbreaking work applying digital tools to Shakespeare's corpus, argue that the Moby text, which is in this case has actual errors in it, it does fine for things like analyzing genre. Hope notes, I suspect it really doesn't matter too much which text you use if you are counting large numbers of frequently occurring items. Maybe if, like Hope and Whitmore, you're using Moby or Gutenberg to make arguments about Shakespeare, it doesn't matter, except that at some point it does matter. When we step back to consider, it's not just that we are using a flawed Shakespearean copy text. Using Shakespeare as a benchmark is that we are choosing Shakespeare itself. Most of the computer science papers that say they're using the Shakespeare dataset offer outputs in the forms of figures and tables about the performance of their algorithm. Usually they test their algorithm on Shakespeare and a couple of other data sets and talk about how fast it is or the processing it takes. These algorithms then are not actually telling us anything about Shakespeare. Shakespeare is telling us about the algorithm. We're so used to the former in digital humanities that the latter can be hard to conceptualize, let alone analyze. The outputs of the papers that use Shakespeare for federated learning, using the Leaf dataset, for instance, indicate the performance of the algorithm. Some of these studies specifically point to the Shakespeare dataset as an outlier. And I quote, the Shakespeare dataset is particularly crucial. This follows likely from the high heterogeneity of the size of Shakespeare datasets. When they say heterogeneity, what they mean is that the length of texts in the Shakespeare dataset range quite a bit. And the reason they range is because, as you see from this visualization by Lauren Ackerman, the amount of lines spoken by a given character in any play is has a huge range, and it always usually follows this zip curve. Okay. Some characters speak a lot, other characters speak not much, and the poems are excluded altogether. The Leaf framework relies on dividing the text into the components' parts, that is, each character's speaking part. It discards the lines of any characters who speak fewer than 2 lines, and the algorithm groups the speeches by the speaker. The emphasis on speakers having their own voices in a play is reminiscent of Mikhail Bakhtin's theory of polyphony, though I would bet my bottom dollar that the data scientists didn't have that in mind when they reduced Shakespeare's work to dialogue for training algorithms. While the Leaf Shakespeare is heterogeneous because of the length of character lines, it is also, compared to other training data sets, homogeneous because it is by a single author. Shakespeare is the only one to have a data set of his own voice named after him. And while the words of others, for instance, in the Twitter data set or in a Stack Overflow data set, are combined into one. I will, of course, step back from my claim to nuance that this is a data set by a single author. We know, for instance, that Shakespeare had many collaborators, including John Fletcher on Henry VIII and George Wilkins on Pericles. So although it might not, and there's tons of work on the field of stylometry to talk about attribution and microattribution studies. And although this data set might not be entirely Shakespeare's own voice, it is presented as such. LEAF is not the only federated learning benchmark to use Shakespeare. In 2021, Jae-Hoon Roh and Ananda Thirsan Suresh created a federated learning simulation, FedJax, that they shared on the Google Research blog, which in their words, aims to make developing and evaluating federated algorithms faster and easier for researchers. FedJax includes 3 components: MNIST62, which is another set for character recognition, Stack Overflow for word prediction, and you knew it was coming, Shakespeare for next character prediction. In their formal research paper, Roh, Suresh, and K. Wu explained the other 2 data sets and what they're for and how they were gathered, but they do not define the Shakespeare data set they use, which we can tell from daisy chaining their citations come from McMahon et al.'s data set, which is used in LEAF. This, as we know, is taken from the Project Gutenberg. Roh, Suresh, and Wu note that their work brings together canonical data sets. Shakespeare is as canonical in machine learning as he is in English literature, and perhaps more so because in computer science, he stands in for an entire data set, whereas, and in the LEAF model and FedJax, other authors are entirely absent. Shakespeare does not just represent all English literature in this model, he represents all English speakers. If for Hope and Whitmore, the Moby Shakespeare is good enough to analyze Shakespeare, perhaps for folks working with neural nets and machine learning, Shakespeare's text is good enough too. But of course, turning and returning and returning to Shakespeare here and in decisions to have him as a benchmark is also a decision to recenter the Anglo, the Euro, and the white. Canonical indeed. The benchmarking of these articles is often about improving the speed of an algorithm, and so here I'm going to turn to another example of Shakespeare's algorithmic test case, which has a more easily understood output, that is, algorithmically generated Shakespearean text. These programs use Shakespeare's text in order to generate what I call Shakespearean-ish texts, as we saw in the prose for a painting example. Let me start with one example in a tutorial titled Predicting Shakespearean Text Using Python Programming Language. This one relies on TensorFlow, which is a deep learning framework developed by Google, and Keras, which is a neural network API, application programming interface, written in Python. After loading this model, which relies on a subset of Shakespeare's plays, and 6 more simple steps, the tutorial concludes by offering some sample outputs, such as some predicted texts for the word shine. Shine on, here is your Virerino Pineat, the Cursu, I'll shine, yet it become done 2K, make you his crowing. You'll notice this output includes results that are not even words. And yet, you'll see at the end, we don't need sentiment analysis to see the angel emoji and think, hey, we did it. This code looks great. The official TensorFlow tutorial it says to users, in this example, you train the model on the combined works of William Shakespeare, then use the model to compose a play in the style of the great bard. And here's some of their results. Love that led me no dumbs lack her burjoy's face with today. The spirit roared, which shames within his powers, which tied up remedies lending with occasion, aloud and Lancaster, stabbed in me upon my sword forever, Agripor, his days let me free. It's better, but not much better. Andre Yi uses TensorFlow and gets this result. Thou art a lodging very good and give thanks with him, but there is now in hand, therefore it be positioned with Romeo dead. I could go on for hours with examples of generated Shakespeare texts that missed the mark, but I'll give just one more. The same data scientist who developed the first tutorial, Andrzej Karpathy, let the neural net run for hours and offered this generated text. Why, Salisbury must find his flesh and thought, that which I am not apse, not a man and in fire, to show the reigning of the raven and the wars, to grace my hand reproach within, and not a fair our hand that Caesar and my goodly father's world. a high school student might not be able to decipher Shakespeare from AI-generated Shakespeare. When I was reading it, I kept thinking it was on the cusp of making sense. All we needed was something to bring it to a grammatical close, and I would be able to understand the parts of this sentence. But it doesn't work yet. Ye concludes his piece with the subheading, "Well, I suppose AI just put writers out of work." He walks it back immediately. Not quite. But AI is making progress in writing Shakespearean text, just as it's making progress in writing all texts. Could an infinite number of monkeys sitting at an infinite number of typewriters produce Shakespeare? Maybe if they had a recurrent neural net. So how does the AI-generated Shakespearean-ish writing relate to Shakespeare the test case? Well, all of these examples I've shared with you have a common Shakespeare, which is not just the text of Shakespeare in general, but two specific digital texts. The first is a data set called Tiny Shakespeare that Karpathy put together, which is a subset of Shakespeare's plays. This data set includes, misses a couple of plays like Othello, Much Ado About Nothing, and the little-known play Hamlet. The data set opens with Coriolanus and ends in the middle of the Tempest. It ends in the middle of a play, covering a number along the way. The second data set that comes preloaded in Google's TensorFlow is the Leaf Shakespeare. Yes, the same one used for benchmarking, the same one derived from Project Gutenberg. Alan Gailey asks, how has the misapplied concept of data obscured the historicity of digital texts like the Moby as artifacts themselves? Thanks to the work of scholars like Gailey, Murphy, and Johnson, we have a much better grasp of how the Moby Shakespeare text informed the circulation of Shakespeare online. Today, I've traced just one way that the Gutenberg text, via the Leaf framework, has now become de facto for training our algorithms. It's the preloaded test case in multiple scenarios, including Google's TensorFlow. When presented as a data set, Shakespeare's works are defamiliarized for many literary scholars, though there are, of course, examples of literary scholars who publish their own data sets of Shakespeare's work and the analysis thereon, like, for instance, Heather Froelich and her piece in Cultural Analytics. When we think about Shakespeare's data set, we have to completely think about, we have to revisit our vocabularies that we use. The word character, the computer scientists will call the roles in Shakespeare's plays devices. We have to learn shared vocabularies in order to discuss this. Just as we can benefit from applying the skills that we've learned as textual scholars to online Shakespeare texts, Shakespeare as data set also could benefit from applying these critical thinking and thinking about how it is made, where it comes from, and also how it circulates and its reception. I thought what I was going to talk about today was Shakespeare as proof of concept, and I have plenty of examples of that, including JSTOR's Understanding Shakespeare, Blaine Gredeman's Shakespeare, and more. But as you can see, I fell into another part of the project for today, Shakespeare, the digital benchmark, and I'd love to hear your thoughts and feedback during our discussion. When we think of Shakespeare as a digital benchmark, it forces us to reframe our traditional discussions of Shakespeare and the digital. The digital tools, algorithms, and machine learnings in this case, aren't telling us anything about Shakespeare, but rather Shakespeare is telling us about the tools. Thank you.